What is linear momentum? The product of mass of the object and the velocity of that object is defined as the linear momentum of the body. The simple dot product of these quantities gives us the value of linear momentum. Note that the linear momentum can be calculated only when there is a linear motion. Hence the object has to move in a linear motion and has to have a linear velocity. To find the force exerted by the object, we differentiate the linear momentum with respect to time. What is angular momentum? Angular momentum has similar meaning to linear momentum, with the only difference being in the terms linear and angular. The meaning of both the momentums are same, with the only difference that the angular momentum is for objects in angular motion. An extra quantity is added while we are dealing with angular motion in addition to the conventional linear momentum equation. That extra quantity is radius of the rotation. In this article we shall study about the angular momentum of a point. How to find momentum of a point. To find the momentum of a point, we have already discussed the formulae in the above sections. For calculating momentum, we multiply the mass of the object with the linear velocity with which the object is moving. For angular motion, we multiply the linear momentum with the radius of rotation of that motion. This will give us the value of angular momentum of point. The frame of reference plays a very important role in calculating the angular momentum. The angle theta affects the value of momentums if frame of reference is to be considered. Is angular momentum same about any point? When a solid rigid body is considered as a system, the angular momentum of all the points on that body will be same. This can be showed with the help of formula of angular momentum. The points closer to the center of rotation will have more value of velocity and less value of radius, and when the point considered is far from center of rotation, then radius value is more and velocity value is less. This way the value of angular momentum is balanced and remains constant throughout. Is angular momentum about an axis or a point? The angular velocity can be considered more about an axis, as the rotation is considered around the axis of rotation and all the points rotating around it have the same value of angular momentum. When taken into consideration, provides less information about the frame of reference, whereas an axis has more information about the frame of reference. Hence we can say that angular momentum is more about an axis rather than a point. How to find angular momentum of an axis? The angular momentum of an axis is nothing different than what we saw in the above sections. The formula for angular momentum that we discussed earlier is the same for both points and the axis. The points lying on the same object have the same value of angular momentum. Mathematically, the angular momentum can be given as L equals mvr. Here the letter L represents angular momentum, m represents the mass of the object, v is the velocity of the object, and r is the radius of rotation. Law of conservation of angular momentum. This law is similar to that of law of conservation of linear momentum. Let us see about the statement of law of conservation of angular momentum in the section given below. The law states that the angular momentum is constant or conserved when there is external torque acting on the object. Hence, until any external torque is applied, the value of angular momentum. Law of conservation of linear momentum. The law of linear momentum is similar to that of law of conservation angular momentum discussed in above section. The statement of law of conservation of linear momentum is given in the section below. The law of conservation of linear momentum states that the linear momentum of a body is constant or conserved until an external force is applied on the moving object. That means the body will have constant linear momentum throughout if no external factor seeps in. Force and momentum relationship. As already discussed, force and momentum go hand in hand. If there is a change in velocity, then there will be a change in the momentum, which in turn will give rise to a force. The relationship between force and momentum is that the rate of change of momentum will provide us with the value of force. The direction of force will be the same as that of the direction of velocity of the moving object. Examples of angular momentum. The list below gives us different examples where we can see effect of angular momentum taking place. Ballerina. A ballerina rotates on her toes. The angular momentum of ballerina changes as her hands spread apart. When her hands are near her body, her rotational speed is more. This is because the radius of rotation decreases. Basketball player rotating ball on his finger? We all have seen basketball players spinning basketball on our fingers. The basketball attains a certain angular momentum due to which it rotates. Fan blades. The blades of fans have angular momentum while they are rotating. The smaller blades move with faster angular velocity and the longer blades rotate with smaller angular velocity. This is an example of conservation of angular momentum. Ice skater. An ice skater also moves like ballerina while performing stunts. While rotating on his skates, the ice skater attains angular velocity. Spinning top? When a top is spinning, the top attains angular momentum. Earth rotation? The surface of the Earth attains angular momentum as it rotates around its axis of rotation. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.